Hello my dear students, once again I welcome you. Today's video is made for class 9th students. In the previous class we have started with the angles made by a transversal on two parallel lines and also the properties of different types of angles. We have learned what is corresponding angles axiom and we proved the alternate interior angles property and the co-interior angles property. Today we are going to do few questions from exercise 6.2. The first question is, in figure find the values of x and y and hence show that AB is parallel to CD. That is, according to question, line AB is not parallel to CD, but AB and CD are two straight lines intersected by a transversal. And we are given the values of two angles here. I give them angle 1 and angle 2. According to question, angle 1 is 50 and angle 2 is 130. We have to find the values of x and y. So this is given angle number 3 and this is given angle number 4. We have to find the values of angle 3 and angle 4, that is x and y, and show that AB is parallel to CD. To prove two lines are parallel, either show a pair of corresponding angles are equal, or a pair of alternate interior angles are equal, or a pair of co-interior angles are supplementary. Here x and y form a pair of alternate interior angles. If x and y are equal, then we can say that AB is parallel to CD. According to question, in figure, angle 1 is equal to 50 and angle 2 is equal to 130. Now, angle 1 and angle 3 form a linear pair, so we can say that angle 1 plus angle 3 is equal to 180. The reason is linear pair. That gives angle 150 plus angle 3x is equal to 180. Therefore, x is equal to 180 minus 50, which is 130. We get x is equal to 130. Now, here angle 4 and angle 2 are vertically opposite angles. Now, angle 4 is equal to angle 2. The reason is they are vertically opposite angles. Therefore, angle 4 y is equal to angle 2 130. That is, x is equal to 130, y is also equal to 130. That is, x is equal to y is equal to 130. X and y are alternate interior angles, so we will write that is a pair of alternate interior angles on lines AB and CD are equal. A pair of alternate interior angles on AB and CD are equal. Therefore, we can say that AB is parallel to CD. So, this is the solution for the first question. The next question is question number 4 of exercise 6.2. The question is, in figure PQ is parallel to ST, angle PQR is equal to 110 degree and angle RST is equal to 130. Find angle QSR. This is the angle QSR. So we have to find the measure of angle QSR. It is given that PQ is parallel to ST. Even if a PQ and ST are parallel to each other, they don't have a direct transversal. So here we need a construction. The construction is, we draw an extra line parallel to PQ and ST through the point R. So I draw a line, let it be XY, parallel to PQ as well as ST through the point R. As a result, we have now two more pairs of parallel lines. They are PQ and XY and ST and XY. Here I give this one angle number 1, this is angle number 2, this is angle number 3, and this is angle number 4. And I give this one angle number 5. Now we have PQ and XY are parallel. So angle 1 and angle 2 form a pair of co-interior angles, and hence they are supplementary. So we will get the value of angle 2. Similarly, angle 4 and angle 5 also will form a pair of co-interior angles. Their sum is 180 because ST is parallel to XY. So we can calculate angle 4 also. Now since XY is a straight line, angle 2 plus angle 3 plus angle 4 will be 180 by the property of a linear pair axiom. So we can find the value of angle 3, which is angle QSR. So according to question, in figure, PQ is parallel to ST, angle PQR is equal to 110 and angle RST is equal to 130. Construction is, draw XY parallel to PQ and ST through point R. Now angle 1 plus angle 2 is equal to 180 because they are co-interior angles, as PQ is parallel to XY. Angle 1 plus angle 2 is equal to 180 because they are co-interior angles, as PQ is parallel to XY. That gives angle 1 is 110 plus angle 2 is equal to 180. Therefore, we get angle 2 is equal to 180 minus 110, which is equal to 70 degree. Similarly, now ST is parallel to XY. XY is parallel to ST, and here SR is a transversal. SR is a transversal. Therefore, we can write angle 4 plus angle 5 is equal to 180 because angle 4 and angle 5 are co-interior angles. That gives angle 4 plus angle 5 is, that is angle RST 130 degree is equal to 180. Therefore, angle 4 is equal to 180 minus 130, which is 50 degree. So we have angle 2 is equal to 70 and angle 4 is equal to 50. Now XY is a straight line. Therefore, angle 2 plus angle 3 plus angle 4 is equal to 180 by the property of linear pair axiom. I substitute the angle 2 is equal to 70 degree plus angle 3 means angle QSR. The full name of angle 3 is angle QSR plus angle 4 50 is equal to 180. Therefore, we get angle QSR is equal to 180 minus 70 plus 50 is 120, which is equal to 60 degree. So, angle QSR is equal to 60 degree. Next, we will do an example question. Example number 5 given in page number 102 of NCERT textbook. The question is, if a transversal intersects the two straight lines such that the bisectors of a pair of corresponding angles are parallel, then prove that the two lines are also parallel. I repeat, if a transversal intersects the two straight lines such that the bisectors of a pair of corresponding angles are parallel, then prove that the two lines are also parallel. So here we have to draw a figure. Let us consider two straight lines AB and CD, which are intersected by a transversal EF at points P and Q. Here we consider a pair of corresponding angles, angle EPB and angle PQD, whose bisectors are PX and QY. According to question, these two bisectors, that is PX is parallel to QY. So we are given two straight lines AB and CD intersected by a transversal EF at points P and Q such that PX and QY are the bisectors of angle EPB and angle PQD. Also, PX and QY are parallel. This is given part. If PX is parallel to QY, we have to show that line AB is parallel to CD. So let us write what is given on the basis of figure. Given AB and CD are two straight lines intersected by a transversal EF at points P and Q. AB and CD are two straight lines intersected by a transversal EF at points P and Q. Also, PX and QY are the bisectors of corresponding angles angle EPB and angle PQD such that PX is parallel to QY. PX and QY are the bisectors of corresponding angles, angle EPB and angle PQD, such that PX is parallel to QY. To prove that AB is parallel to CD, if the bisectors of a pair of corresponding angles are parallel, then prove that the two lines AB and CD are parallel. Here we don't want any construction. Anyway, I give this is angle 1 and this is angle 2. Angle 1 is half of angle EPB because PX is the bisector of angle EPB, and angle 2 is half of angle PQD because QY is the bisector of angle PQD. So angle 1 and angle 2 are the halves of a pair of corresponding angles. So I go to the proof directly. Given Px and Qy are the bisectors of angle EPB and angle PQB respectively. Therefore, angle 1 is equal to half of angle EPB and angle 2 is equal to half of angle PQB. It is given equation 1. Now we are given Px is parallel to Qy. Given Px is parallel to Qy. Px and Qy are the bisectors of a pair of corresponding angles, angle EPB and angle PQB. They are given parallel. If you take Px and Qy separately, which are parallel, I draw Px and Qy separately, which are parallel. Here you can see that this EF is a transversal for Px and Qy also. If you consider only Px and Qy, which are parallel to each other, for Px and Qy, EF is also a transversal. Therefore, definitely these two angles are equal. These two angles, if you compare with this figure, it is angle 1 and it is angle 2. So we can say that given Px is parallel to Qy and EF is a transversal. Therefore, we can say that angle 1 is equal to angle 2. Because for Px and Qy, if EF is a transversal, angle 1 and angle 2 form a pair of corresponding angles. So the reason is they are corresponding angles. Angle 1 is equal to angle 2 means we can replace angle 1 with the half of angle EPB and angle 2 with the half of angle PQB, that is using equation 1. Cancelling half from both the sides, we get angle EPB is equal to angle PQB. Cancelling 1 by 2 from both the sides, we get angle EPB is equal to angle PQB. Angle EPB and angle PQB are a pair of corresponding angles for lines AB and CD if EF is a transversal. So we can say that a pair of corresponding angles on AB and CD are equal. That is, a pair of corresponding angles on AB and CD are equal if a pair of corresponding angles made by a transversal on two straight lines are equal, then the two straight lines are parallel. Therefore, we can say that AB is parallel to CD. That is, if a transversal intersects two straight lines such that the bisectors of a pair of corresponding angles are parallel, then the two straight lines are also parallel. That is all for today. We will meet in the next class with some other topics. Till then, take care. Goodbye.